In this video, we're going to evaluate exponential expressions, graph exponential functions, and solve exponential equations. So for problem 1, we have 3 exponential expressions to evaluate. This calls for a calculator, either a graphing calculator or a scientific calculator. So number 3, or number 1, part A, it's 3, and then we have to take that to power of 2.133. Hit enter. And we get 3 places, 10.416. For part B, we have the exponential e. So let's get second here. Get this expression here. And then we enter a negative 2.4, close the parentheses, hit enter, and we get negative, or I should say a point 0.091, point decimal 0.091 to 3 places. And then for part C, we have 4. Taken to the, okay, so an exponent here be the square root of 3, close parentheses, we hit enter, and the 3 decimal places, 11 decimal 036. Now in the next problem, number 2, we'll be graphing exponential functions. So your basic exponential function has the form f of x equal a to the x, where x is any real number. And we're going to look at 2 cases. In one case, the base has to be greater than 0, but less than 1. In another case, the base has to be greater than 1. So let's look at this one then. Let's look at the case where the base is greater than 1. So 1.2, 3, 3.5. If the base is greater than 1, we let x be 0, then I'll get a to the 0 is 1. So I know that the graph is going to pass through this point right here. That's a y-intercept, 0, 1. And notice that's as the x value increases, let's suppose the base is 2. So 2 to the 0 is 1. 2 to the 1 is 2. 2 to the second is 4. So you can see as the power increases, the value of the function increases. If we go the other way, on the negative side, 2 to the negative 1 is 1/2. 2 to the negative 2 is 1/4. So as we go through the negative side, the value of the function increases. So basically this graph goes like this, goes up like this, approaches the x-axis, and then it crosses at the point 0, 1, and then it rises. That's what the graph looks like. You can see the domain here, there's no restriction. The domain is going to be all real numbers. And the range, well, the y value is going to get close to 0, but it'll never get to 0. So it's going to go from 0 to infinity. That's the range. Now if it's the other way around, let's say the base is 1/2. In other words, the base is between 0 and 1. 1/2 to the first power is 1/2. 1/2 to the second power is 1/4. 1/2 to the third power is 1/8. So as we go through the positive numbers this way, the graph's going to come down. And for the negative numbers, notice if I make this a negative 1, this will be 2. If I make that a negative 2, this will be 4. So on the enter the negative values, it rises. That's what the graph looks like. So if you pick a base between 0 and 1, it's going to pass through 0, 1, rises on the left, and then it comes down and approaches the x-axis. So in either case, the range, or the domain, is going to be all real numbers, and the range is going to go from 0 to infinity. The other one goes this way. So we want to graph this here. So consider your typical base. So we got, for the first one, graph the function, and it has f of x. And let's just look at 4 to the x. So this is the case. This is the case where the base is larger than 1. So we know it's going to pass to this point right here, 0, 1, and then it's going to go up like this. The domain will be all real numbers, and the range will go from, the 0 is not included because it doesn't touch the axis. So it'll be like this. That'll be the range. To denote all real numbers, we simply say all real numbers, or you can use interval notation. Say negative infinity to infinity. Okay, that's what we would have if we had this graph, but we have this graph right here. So what does this do? Well, the expression here, the x minus 2 here, if I didn't have that minus 2 there, I just had the minus 2 over here on the right, then it would be this graph here, same graph, like this. The minus 2 takes it 2 down, because it's negative. But because I have the minus 2 here in the exponent, what it does is it moves this over 2 units to the right, and then 2 units down, because of this. So instead of having the horizontal asymptote at the x-axis, you're going to have it right there. And this is going to go up like this. And that would be the graph for this one here. So you want the domain. The domain will be negative infinity to infinity. The range, the smallest value for the y value would be up to the asymptote. Doesn't touch it, so we put parentheses like this and say it's negative 2 to infinity. So we got the graph, domain, the range, and then for the horizontal asymptote, instead of y equals 0, everything moves down 2 units, it'll be y equal to negative 2. And that's what the graph would look like. We have the domain, the range. Now let's look at the next one. F of x equal to 3 to the minus, or 3 minus e to the minus x. Well, let's look at e to the minus x. That would be the same thing as 1 over e. In other words, I'm writing this to apply the negative to this. Let me break it this way so you can see what I'm talking about. It's going to be e to the minus 1. I can write it this way. And this, of course, property of negative exponents. I can write it that way. And e to the minus 1 is 1 over e. And then I can make this positive here. And e, of course, is approximately 2.72. So this is less than 1. So this will be the case then where this is coming down like this. If I just look at this part right here, okay? So let's just look at this part right here, which is this. The base is less than 1. So the graph is actually coming down this way. Okay? The base is larger than 1, it goes up. It rises, in this case it decreases. And then what does this negative in front here do? This flips it. This is reflected over the x-axis, so it's going to be coming down over here. This way. This way. So this is going to come down this way here. It would have the asymptote here at 0. But then the plus 3 moves it up. It's 1, 2, 3. And then of course this is going to move up. So the horizontal asymptote, instead of being y equals 0, is y equal to 3. So we have then the domain, still no restriction on the x, is going to be from negative infinity to infinity. The range starts on the negative side and goes up to including 3, but not including the 3. So parenthesis here, from negative infinity to 3. And then of course the horizontal asymptote is y equal to 3. So we start off with your basic one here. It was coming down like this. And then the negative reflected it. And then the 3 that was added moved it up 3 units. So the horizontal asymptote wound up at y equal 3. Now let's look at some exponential equations. And here we're going to use the property that if you have a base a to the x, and that's equal to same base to the y. And this is again, I want dealing with just positive bases, so the base is positive, and I don't want it to equal to 1, because 1 to any power is still 1. So notice 1 to the 10th is still equal to 1 to the 5th. 1 to the 10th is 1, 1 to the 5th is 1. So that's why I want the base to be not equal to 1. Otherwise, what I'm going to say, it's not going to work. So as long as we have the condition where the base is positive and not equal to 1, and if I have this situation here, x base is the same, and you have this equality, the exponents have to be equal. X has to be y. So over here, let's just rewrite this. So it's 2 to the 3x. And notice 4 is the same thing as 2 squared. So let me rewrite 4 as 2 squared. And then the exponent is x plus 1. Power to a power, I multiply the exponents. And here I'm just trying to get the base the same. So 2 times that. So this will still be a 2 here, the base. The base changes to 2, and then this 2 multiplies that. So it'd be 2x plus 2. Base is the same. I can equate the exponents. So 3x has to equal to 2x plus 2. Subtract 2x from both sides, and I get x equal to 2. The 2x, the 1x, x would be 2. And that's the answer to part A. And for part B, I already have the same base. I got an e here and an e here. The bases are the same, so I can equate the exponents. So that tells me that x squared, the exponent on the left side, has to equal to the exponent on the right side. That's 3x minus 2. I just have a quadratic equation to solve. Let's bring the 3x over, make it a minus 3x. The minus 2 comes over, make it a plus 2. So I added a minus 3x and a plus 2 to both sides to make one side 0. And then I factor this. X minus 2. X minus 1. Solve any quadratic by factoring. So factor it. And then we set each factor equal to 0. X minus 2 will be 0 when x is 2. X minus 1 will be 0 when x is 1. So the solution is x equal to 2 or x equal to 1. And you can easily check this by plugging in there. Thanks for watching. We'll see you next time.